Hello, so good evening. So in continuation of the reactions on, so about the lecture on free radicals. So let us continue the reactions on reactions of free radicals. Okay. So today I will take up the reactions of free radicals. Free radicals can undergo many types of reactions. So I will write down here. First one is Coffering reactions. Coffering. And second one is cyclization, and third one is abstraction of an atom, attraction of atom or group of atoms or group of atoms by radicals. Fourth one is addition reactions. And then we can have free radical reductions, then rearrangement. Okay, so these things we'll discuss today for reactions of free radicals. So free radicals, I will repeating again. Free radicals can undergo reactions like Coffering reactions, free radical Coffering, radical cyclizations, abstraction of atom or group of atoms by free radicals, and addition reactions to multiple bonds and reduction, and then finally there we have rearrangement. Okay, rearrangement reactions. So let's say one by one. Okay, free radical Coffering by free radicals. Free radical Coffering. So here two radicals can combine together to give a neutral molecules. So it involves, I'm writing here, it involves the formation of a sigma bond, between two radical carbocation. We can say two radical carbon atoms. We can say centers. You can say centers, two carbon centers. To give a neutral molecule. Okay. So many examples are here. So generally I can write down two radicals. There's another one prime. Okay, you can give Coffering together. So one here coming together. So that gives a sigma bond is formed to get the neutral molecules. Okay. So many examples. Bromide radicals gives bromine, and then CH3 to Coffering together to get the ethane. Okay, so they are neutral molecules. Even this, you can see this one. Okay, this compound, this triphenyl methyl radical will give these three phenyl groups are here, phenyl, and then we can have another phenyl group. So you can try this as a home assignment. You can try this mechanism of the reaction. Okay, here phenyl hydrogen here. So this is a product. The Coffering reaction takes place, but in the site rearrangement takes place. So I'm repeating again that here in the case of radical Coffering, free radical Coffering, it involves the formation of a sigma bond between two radical centers to give a neutral molecule. Okay, so I'm giving some examples here. To bromide radical to the bromine, and methyl radical with the ethane, like this. Okay, so example. Now let's come to the second reactions. There is cyclization, radical cyclizations. So intramolecular reaction takes place here. So let's have second one is radical cyclization. Okay, radical cyclization. Here, free radical cyclizations can occur. So I'm writing down here. Free radical cyclization can occur following radical addition to 1,5 or 1,6, depends on the number of carbon atom once it dienes by intramolecular is intramolecular system. Cyclization takes place intramolecular addition leading to a cyclic product, cyclic compound, cyclic product. Okay, many samples are here. I'm giving some, for example, I'm giving here, so like this. So this is 1, 2, 3, 4, 5, 6, 1, 6 tie-in. So this is a 1, 6 tie-in. Let us react with another radical here. So this will give attack here first. This attack here. Fish hook. Arrow are here used. Okay. So here attack. Then this becomes radical here. So here radical. Then this becomes CH2 here and phenyl here. Okay. So now you attack this. Then cyclization, this now cyclization takes place. This one attack here, this attack here. So it becomes another product here. Cyclization to 5-membering. Okay. The 5-membering comes. Here CH2, phenyl, and this one CH2 radical. Okay. Then we can attack by bromine. Agglomeration takes place to give this 5-membering. CH2 phenyl and then CH2 Br. Okay, bromide attack here, so we can get this one plus bromide radical. Okay, so this is our one example I'm giving. So I'm repeating again. Critical can undergo cyclization, by which can be followed by addition to 1, 5 diene here, 1, 2, 3, 4, 5, 6, 1, 6 diene. Okay, reacted by radical to give an cyclization takes place, and again finally termination takes place to the final product 5-membering. Similarly, generally we can form also 6-membering here. If we attack here, then we will get the 6-membering. But generally, 5-memberings are more stable than 6-membering. Okay, so due to the study of this, para-alkyl radical is formed. So 5-memberings are much better than 6-membering or 4-membering. So now let's come to another third reaction type of free radical mechanism. So here we have abstraction of, third one is abstraction of atom or groups of atoms by free radicals. Okay, so here you can say radicals react with saturated. You can write down radicals. I can write, okay, radicals react with saturated alkenes, saturated organic compounds, you can see compounds by abstracting an atom. Usually hydrogen also can be usually hydrogen atom from carbon atom. So this is so for generally you can say, so this, let's say this one carbon hydrogen, then radicals can extract here, extracted radical, and then given here. Okay, so you got another radicals here. Plus RIs. So here I'm giving example of abstraction of hydrogen by radical. So radical can abstract. Even the allylic compound also can be another example, say CH2. So they can undergo some rearrangement here. So like this will go. Allylic radical can be also undergo rearrangement. So you can have this one and this CH2. Okay, rearrangement takes place. So suppose it's R here, which one is more, depending on the positive, there is R group, then radical which is more stable form, secondary radical or tertiary radicals are more stable than primary. So depending on the, let's say this R here, CH R here. Okay, and then this will be more stable. Instead of forming here is radical, so this will be much better because this is secondary, this is primary. So depending on the nature of the formation of the radical, so you can give stable one. Rearrangement also can take like this. So let's see another. I'm repeating again. So here radicals can abstract an atom or group of atoms from organic compounds. So here usually hydrogen atoms are commonly used. They commonly restricted by free radicals. So I'm giving one example here. Generally, so allylic radical also can be rearranged to give the more stable free radicals. Okay, so this R can be this group. So now we can have another one. Fourth one is another reaction type is addition reactions. Addition to multiple bonds, or double bond or triple bonds. Okay, so here free radicals can add to double bonds like double bond, then another free radicals this one. So if you take here, then this one like this. So mechanism is this one, then R is formed. So here addition takes place to give another addition of these free radicals to multiple bonds, give another free radicals. So here one example, generally you can say suppose R here, substitute the bonds. Another example is C2 CH, let's say X. Okay, let's say R here, attacks here. So it doesn't attack here because it takes to the here only. Okay, another one here. So it gives, you can get, it doesn't attack here, but it gives R CH2 CH X. Okay, here radical is coming here, this is carbon atom, and it doesn't attack here. Here suppose if you attack here CH2 CH X R. So here, suppose R attacks here, then it will go this way. So it's giving this one, but generally it doesn't form. Okay, because this is this radical is secondary and this one is primary. Well, it doesn't depend on the X. X can be any substituents. So generally this is from this one part is formed because this is primary radicals and this one is secondary radicals. So I'm giving one addition to double bonds or multiple bonds gives another radicals. Always can be undergo further reactions to give finally to give the lithium compound. So I'll give one example here. It depends on the anti-Markovnikov rules. So addition of ISBR to this compound. So let's say CH2. Okay, CH3. One example I'm giving addition of free radicals to multiple bonds to these olefin compounds. So here let's say ISBR. So initiator here using peroxides. Okay, pardon. So here it will give the pass with the presence of light. The initiator it comes like this. So the product will be CH3, and then the hydrogen will be here, and CH2Br. So this is anti-Markovnikov's addition takes place here. This is only one product, radiospecific. The product is only giving one specific and anti-Markovnikov addition. Markovnikov addition production takes place. Okay. So your product is not here. Here bromine doesn't come here. Bromine comes to the CH2 here. So the mechanism we can have physical. You can apply the physical mechanism here. So physical mechanism takes place. First the initiation. Physical mechanism we can have initiation, propagation, and final terminations. So we can apply this here. So first step is the initiation step. Initiation initiation, free radical mechanism here. Initiation step is fast. Okay. So here peroxides or in presence of light, it gives this one here, broken down the ring, but on the bone here, bone is broken down here. So we got 2RO. Okay. So this O can attack with the hydrogen here, reaction with hydrogen bromide is Beer, then reacts with this OR, and can have water, and then so you can say alcohol, ROH, and then bromide radical. Okay. So this is the initiation step. Initiation step is here using the initiator is the peroxide. Initiated in the presence of light, you give the radical. That this radical can attack to the ice bear to give the bromide radical. So this is a fast step, initiation step. Then we have the next step is propagation. Now I think this. The next is propagation step. In the propagation step, so the propagation step. So free radical mechanism involves 3 steps: initiation, propagation, and termination. So in the propagation step, the compound as one substrate reacts by these radicals. This is CH3, okay. So here, attack here, and then they go this way. So it gives the another radicals, CH3, then CH2, Br. Okay. So in this way, initiator may go up, further reaction may undergo like this. Then this another here. This radical can attack another ice bear molecules. So CH2Br and CH3. These radicals can go and attack with ice bear. So these radicals can attack this, absorb this, and this one. Okay. Like this. Okay, so we have protonation here of hydrogen comings, and then we have CH2, Br, then another Br radicals here. I think right down here, plus Br radicals. Okay, the CH3 here. So this is a product. So this is a propagation step. Finally we have termination step. Termination step means these radicals can combine together. Coupling reaction takes place. 2 radicals like Br bromide plus another bromide radical can Br2, or this one can coupling with another radical like this. So this radical can combine another radical or can give this formulation also takes place like this. So it depends coupling. Here in the termination, coupling reaction takes place. 2 radicals combine together to keep the neutral molecules. So about free radical mechanism, we have initiation using the initiator, light or pyrolysis. Initiation step, we give the free radicals. Then in the propagation, free radical attack to the neutral molecules, organic substrate, to give another free radicals. So this then the final termination step is 2 radicals coupling together to give the neutral molecules. So this is about the addition. Now let's come to reduction, free radical reduction. Radical reduction. You can say radical reduction. So radicals can undergo reduction also takes place. They use, so this is mostly found in bark reduction. Bark reduction. Bark reduction. So here already the acetylenic compounds can be used by using the metal in liquid ammonia in sodium metal, and in low temperature around 33 minus 33 degrees Celsius. So it can give this 2 hydrogen reduction takes place in presence of liquid ammonia. So this hydrogen here is mostly in the trans system, okay, RR trans. So it is Bach reduction, and even the aromatic compounds also can be reduced using the same sodium in ethanol. Bach reduction, here the Bach reduction liquid ammonia and a very low temperature around minus 33 degrees Celsius. So it gives diene, okay, cyclohexadiene gives. So this here I'm giving involves free radicals. The radicals coming from the metal. Metal gives supplied electrons and it gives like this electron. So undergoes ejection. So these are another Bach reactions. Then we can have another rearrangement reactions. So free radical can undergo rearrangement to get the more stable free radical. So here there's the rearrangement. So this is the last one, rearrangement of free radical reactions. So here I'm writing the free radicals may undergo free radicals may undergo rearrangement to form a rearrangement to form a more stable radical, and then the final product. Then the final product attacked by the another radicals are the combination final product. Okay. So I'm repeating again. Radicals may undergo rearrangement to form a more stable radical and then final product. So for example, there is this one. This is okay. Another. So here is R. Okay. R. So here is a primary free radicals. So you can rearrangement takes place to keep the here. So you can have these two combined together. So you can have C R CH2 R is migrated to the CH2 group. So here becomes the radical here. So this free radicals is now tertiary. Okay, so tertiary more stable. So migration takes place, rearrangement takes place to give the more stable radical. So here free radical, I'm giving many examples. So I'm giving one general examples. Now let's another one important element. In this case, we can have very important. In the case of free radicals, we have another one, allylic rearrangement. Okay, allylic bromination. You can say allylic brominations. It's very important about the free radical reactions. Allylic bromination. You can say Uhl-Ziegler. Name of the reactions is Uhl-Ziegler GLER reactions. Okay. Or you can say rearrangement. So this is one of the most important radical allylic bromination is the reactions of the free radicals. So here I can write on here. Alkenes can be brominated. In the allylic positions using NBS, N-bromosuccinimide. Using NBS means N-bromosuccinimide. Okay, succinimide, the reagents, brominating reagents here, and the reaction is known as. Uhl-Ziegler reaction. Okay. So I'm repeating again here. So free radical allylic bromination can take place by alkenes having alpha hydrogen atom can undergo bromination in the allylic position using NBS. So here, generally reactions can take place like this: CH2, CH2. Okay, let's say R here. These allylic positions. Okay, alpha hydrogen atom here using NBS, and then the solvent is the tetrachloromethane, and in presence of light. Okay, so you can have this will take H2, C down one CH R. Okay, the formation takes place here. Not bromide. Here bromide can attack to the double bond. Here bromide attack to the allylic positions. So this is general mechanism, general reaction. So alkenes can be converted in the allylic position using N-bromosuccinimide. So let's see the mechanism how the reaction takes place. Here bromine is supplied from NBS, N-bromosuccinimide. So let's see the mechanism of the Uhl-Ziegler reactions mechanism. It's one of the most important reactions of free radicals. So here we have N-bromosuccination, and okay, let's say the oxygen double bond O, the NBS. It is NBS bromination. NBS is NBS, N-bromosuccinimide. Okay, NBS reacts with hydrogen bromide. That's it. And then in presence of tetrachloromethane, can have this tautomeric form. So here, first step is formation of this succinimide NH. This succinimide. Okay. Succinimide. Then we have bromine here. So this is the, as you take this hydrogen here, and we come to this way, the bromination comes. So this is N-bromosuccinimide. This is NBS means N-bromosuccinimide. Okay. So first step is mechanism. First step is NBS reacts with hydrogen bromide to give the succinimide bromine. This bromine, the initiation step, reacts with say light, in presence of light. So we got this radical, okay, bromide radical. So this is the initiation step. Then again, this next step I write down here is bromine attack to the organic substrate. Let's say organic substrate. This way, let's say example. Say let's say R, CH, double bond CH, then CH2. Okay, let's have hydrogen here, then R prime. Okay, then now reacts this the bromide radicals. This bromide radical from the light initiation step attack here. So first attack to the hydrogen. Okay, attack to hydrogen. You can write this way, or these two are hydrogen combined, and then here. So first step is formation under. This is propagation step. So here bromide doesn't attack to the double bond. Okay, attack to the hydrogen atom here in the allylic positions. So we got CH R prime. So and then here we got this radicals. Then we have these are hydrogen combined with bromide. We have HBr. Okay. So this is propagation step. We form another radical is formed. So this radical can react with another bromine. Then we can have. So this next step is next step is this one R CH double bond CH R prime, but reacts with another bromine molecule. This is bromine molecule. Okay, so bromine molecule Br2. So I'm writing here this way. So this attack to this one, this bromine, another one here bromine, and then bromide. Okay, another bromide is formed. So here we got a allylic bromination and allylic position comes. C is Br R prime. So we have another Br. You can see here Br bromide radical. Okay. So this is the reactions, propagation reactions. So finally you can have termination to this bromide. Termination can take place. Bromide to Br, okay, Br2. bromine molecule. Okay. So I'm repeating again. In the Wooljager reactions, first initiation step is from the suction NBS and bromosuccinamide. And by reacting with ISBR, we got the bromine. Then bromine reacts with this light initiator to get the bromide radical. This bromide radical attack to this organic substrate in the allylic position. It doesn't attack to the double bond. It doesn't attack here. It attacks to the allylic position. Allyl hydrogen extract that takes place to the ISBR. Extraction hydrogen takes place here. Then finally, bromination to the allylic position to give the pyridine product, and then termination takes place to bromide radical can attack, can give to this one. Okay. So here the termination takes place, or you can this one termination. We can have also this another way for formation of this or prime. You can get with another bromide here. So you can two radicals are coupling together. So we can get some product. We can get another termination reactions. R prime Br. Okay. Here bromide radical attacks here. So coupling takes the two radicals coupling together to keep the final product substrate. So this is about the Wooljager reactions. So this is about the free radicals I am giving here. So you can all the reactions of today I am giving the reactions of free radicals. So I will give some reactions on applying this Wooljager reactions, some examples. So you can try the mechanism at home as an assignment. You can try this one. So I'm giving some allylic combination of cyclopentene. So cyclopentene, okay. So let us say 2 hydrogen atom here. So allylic. So combination will be allylic NBS and bromosuccinamide, carbon tetrachloride, then ISBR. No, not ISBR. ISBR will come here from the bromosuccinamide. Then you can have light or photolysis, and peroxide can be initiated here. So you can get the product. So you can write. You can use only one product. Here you can give only one product. Okay. You can give only one product in the allylic positions. Yeah. Here bromide doesn't attack in the double bond. So yeah, only one product. It gives only one product. But if you use this one, another one, if you use this one, and CH3 in allylic hydrogen, yeah, we have allylic hydrogen. When you use the same reactions, you do same reaction mechanism using peroxide, this one. But here we didn't get, we didn't this one hydrogen. Okay, this hydrogen here. It doesn't keep reaction doesn't take. So bromine here and CH3. So allylic position bromine plus. You can have another one. So yeah, rearrangement takes place. Here you can have rearrangement of the double bond takes place, and then we have CH3. I think you can see this. Okay. So here, this is your major product. This product is major, this is minor product. So then rearrangement takes place. And double bond has been shifted here in the case to get the product. So this, you try this as a home assignment. Okay. So let's do one up here for today. So I'm giving reactions of free radicals for today only. Okay. So next class I make carbocations. Okay.